Okay. Yeah, arteries and vein, a good example of what kind of connective tissue? Mucus. Remember, the whole point about mucus connective tissue is that the ground substance doesn't have a lot of fiber. It's just chock full of ground substance that's very hybrid, a lot of proteoglycan, so that it can be compressed, and then after compression, it will spring out. That's why if you think about your intervertebral discs, which are a circular kind of disc-like structure surrounded by fibrocartilage, but in the internal portion you have a nucleus pulposus, which is mucus connective tissue, which is compressible. So we're all walking, as Nigel pointed out, fighter pilots after they eject, and we're starting to compress that, right? So that kind of force isn't tolerated, but the everyday-to-day walking around, running, jumping is cushioned by the mucus connective tissue in the intervertebral disc. All right. So that's connective tissue proper. Getting into supporting connective tissue. What are we looking at here? Or it could be, with an H&E city, elastic. Turns out this is hyaline, but I just want to point that out. All right. Spaces above and below are arteries. All right. The perichondrium should be a nice layer. You can see nice lacunae with chondrocytes in it. You see lacunae that are smaller here. These are the chondrogenic, this is the chondrogenic layer of the perichondrium. These puppies will develop into full-fledged chondrocytes and larger lacunae. This would represent them what kind of growth? Growth from the surface and appositional. Here we have an isogenous group. So this are two daughter cells from one mother cell, if you will. This would represent what kind of growth? Interstitial. So you have both going on in cartilage. Here you get another shot of hyaline cartilage. Here, look at this tetrad here. These two divided into the daughter cells. It lets you know that it's actively being actively growing. Elastic cartilage. All right. So let me step back. We have a slide in that we actually look at elastic cartilage. And at the end, we ask a little written blurb in the lab, and we ask where do you find it in the body. Okay? And what I want to say is, like with the epithelium, I'm expecting you, we are expecting you to know where you find each one of the tissues in the body. That's what we call book knowledge. That's your foundational base. If you have a good book knowledge foundation, then you can use what you see, what you observe, to figure out where you are. That slide of elastic cartilage, for those of you that haven't worked it out, spend some time working it out. You know, clues that you're going to look for. You know, circumnavigate the section. Am I looking at a natural edge or a cut edge? If it's a natural edge, then you got to start thinking, well, what tissue lines natural edges? Epithelium. Next question is, what kind of epithelium? Use clues like that with your book knowledge foundation, you can figure out what you're looking at. So at any rate, we've got elastic cartilage here. Here is a shot of fibrous cartilage, which is a hybrid between a fibrous connective tissue and cartilage. Right? Fibrocartilage is unique in two respects that I can think of right now. One, it doesn't have a perichondrium, which is kind of found inside you. And two, it's got collagen type 1 organized into fibers. Right? Remember, hyaline and elastic have collagen type. It has collagen type 2, like hyaline and elastic. But type 2 only forms fibril. It doesn't organize into the larger fiber. Now you can get a sense that there are fibers here. And you can play that game with the aperture diaphragm, shutting it down here. You don't even have to do that. You get a sense that there's fibers running this way that organize the chondroblasts in their lacunae on top of it. All right? And again, you need to know where you find fibers. It helps figure out where you are. Okay, we're into bone. If we think about bone, we got to think about a series of cells, and we need to ask ourselves, are the cells on a bony surface, or are they surrounded by bone? Okay? One thing to keep in mind is that generally, if you look at a slide that has both cartilage, hyaline cartilage, and bone in it, the lacunae of bone are small. Right? Generally a reasonable observation. So keep that sense of scale in you. All right, a cell that is completely surrounded by bone in this trabeculum here is what type of cell? All right, and it's derived from what type of cell? All right, so osteoblasts are usually on forming bone surfaces. Okay. When they entomb themselves in bone, they become osteocytes. Remember that they're connected with every near neighbor via what? Canaliculi that actually contain processes of the osteoclast. So, if we look at these cells right here on this bony surface, they look relatively plump, right? Those are going to be osteoclasts. If we look at this surface right here, they look more flat. Those are going to be bone lining cells. Bone lining cells are just osteoblasts that are taken apart. Okay? They're quiescent, if you want to be a little bit more fancy. Now, what's the other cell that we find on bony surface? Osteoclast. We'll get to that in a minute. So here's an electron micrograph comparable to what Mike was showing in his lecture. We haven't decalcified the bone, or calcified matrix, or osteoid that's got calcium hydroxyapatite in its blast. This puppy is entombed by calcified matrix, so by definition it's a... This one, we're at a low enough power, but I'll just tell you, is in the conversion canal, so this would be a osteoblast. It's not entombed, right? If we can't, just right here, this could be osteoid. It's not completely calcified. Note that we're connected by a gap junction, processes of individual osteocytes or osteoblasts are electrically and metabolically connected because we've got that gap junction. Okay, so we've got a bony trabeculate, we've got what here? What about here? Here and here. Yeah, they're really unique cells. I've seen up to 7, 8, 10 nuclei in one osteoclast. Right? So they're multinucleate on a bony surface. We've got out here is marrow. And if we look, this is that scanning electron micrograph that I showed you. This puppy should flip back in here. But if we look in the resorption bay, or Hist lacuna, we can pick out individual collagen type 1 fibers that are part of the osteoid. Because this puppy was active, decalcified the matrix. If you look at this cell, you can see that the large, particularly in this region right here, trust me, that's all the way around it. It's relatively smooth. That's called the clear zone. That's basically the seal, the way the cell seals itself to the surface. Here the ruffled border is where they're cranking out the hydrogen chlorides and whatnot that dissolve it. So it's clear you don't want those acids going everywhere. You localize it by sealing the cell to the surface. And I've got an electron micrograph which shows that. So if we section the cell like this,